Alright, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give some lecture on simple linear regression before we start with the demonstration. Right. So, what is simple linear regression? So, actually, a linear regression is actually a statistical methodology that utilizes relation between continuous or numerical variable so that one variable can be predicted or estimate. Right. So this is example of simple linear regression. We have one continuous independent variable and one continuous dependent variable. In this example, we have food intake will predict waist circumference. Right. So in simple linear regression, right, we can answer two research questions. The first one is, does the amount of calorie taken associate with the body weight? It actually can measure the relationship between two continuous variable where we have independent variable and independent variable, and the plus value that we can obtain from a simple linear regression is, we would like to ask, would the amount of exercise in hour predict the change in blood pressure? Means that we can do some prediction in simple linear regression. Right. So this is another example. How much will 1 gram of salt change blood pressure in mmHg in Perak population, where we have independent variable is the amount of salt and the dependent variable is the outcome variable where we have the blood pressure. The blood pressure dependent variable should be continuous variable and independent variable should be also continuous variable. Right. So in linear regression, it measures linear association between continuous variable, and it is also useful when dependent variable and independent variable are clearly specified. We already identified the dependent variable and independent variable, and it also applied when the prediction in the outcome variable is the amount of the objective of the analysis. Right. So the dependent variable, let me make it clear. What is dependent variable? It's also known as outcome variable, response variable, responding variable, or regression. Is the variable that a researcher would like to examine if an independent variable change. For the independent variable, is a change in the value of it will change the value of the dependent variable. So the uses of linear regression, I have listed 4 uses of linear regression. First is, we can assess linear association between dependent variable and independent variable, and then we can also determine the change in value of the dependent variable when independent variable change in particular unit. And we also can use to predict the value of dependent variable for a specific value of the independent variable. And lastly, we can use to control for confounding index, confounding effect of the independent variable, which is in multivariable analysis. So the formal definition of simple linear regression is a statistical methodology that utilizes the relation between two continuous or numerical variables so that one variable can be predicted. In simple linear regression, there are only one dependent variable, or what we call as outcome variable, and another one independent variable, which is a predictor variable. Right. So there are 6 assumptions in simple linear regression. So first, we need to know what is the dependent variable and independent variable. The first assumption is the value of independent variable is fixed or non-random or a mathematical variable. Second one is the independent variable or x is measured without any error. So the third assumption is for each value of x, there are subpopulation of y must be normally distributed. So the fourth assumption is the variance of subpopulation of dependent variable are all equal. And number 5, the mean of subpopulation of dependent variable y all lie on the same straight line. This is the assumption of linearity. And the last assumption is the dependent variable y has a value that are statistically independent. These all 6 assumptions can be concluded as line, where line represent linearity, independence, normality, and equality of variance. So the linearity means that the relationship between x and y are linear over the range of value of studies, and independence means that we collect the data from independent sample. Right? Normality, the response variable y has a normal distribution at each value of exploratory variable y, x, and the equality of variance means that the distribution of y has equal variance or standard deviation at each value of x. That is, standard deviation of y is same no matter what the value of x. So how to measure the linearity, independence, and normality and equality of variance? So for linearity, we will use scatter plot between residual and predicted value, where the x value will be the predicted value and y value will be the residual value. Independence should be settled during the study design stage. Normality, we will measure the residual, the normality, the distribution of residual by using histogram and box plot. And the last assumption, which is equality of variance, we will use a scatter diagram between residual and predicted. This is same as linearity is checking, XPYR, right? So for linearity and equality of variance, we can use scatter plot to plot between residual and predicted value. If you have this kind of pattern, this pattern shows that there are no pattern at all in the scatter diagram, so then we can say that the linearity assumption is met. Same goes to equality of variance, right? If there are no pattern, means that the distribution of residual and predicted are scattered around the graph or canvas, means that the equality of variance is also met. So if you see any patterns, right, whether is a U shape or V shape, right, or any shape, right, means that the equality of variance and linearity of assumption is not met. Okay. So next, this is a simple step, 7-step for simple linear regression, right? First, we need to explore the data, where we need to describe the data, create a scatter plot to see the relationship between the variables, independent variable and dependent variable. And then number 2 is we fit the least square line, where we're going to use least square method to fit the linear regression. And number 3 is we're going to evaluate the fitness of regression model, evaluate the importance of independent variable by looking at the B or beta 1 or slope of the regression model. And number 5, we're going to do a residual diagnostic to check the assumption. Number 6, we're going to interpret the result. And lastly, we're going to do prediction, right? So conclusion, right, for this lecture, before we go for a demonstration, so correlation differ from regression. This is the thing that we need to remember. Apply proper step in analyzing linear regression. Assumption and diagnostic checking must be done when we establish a simple linear regression model. We need to know how to interpret linear regression output from R and properly present linear regression result, And lastly, linear regression can be used for prediction. As for a recap, right, so need to think from my lecture today what we have learned as far. Now I know the simple linear regression, so now I want to do more about simple linear regression in R. Thank you very much. I think next we will go for demonstration.